Hey everybody, welcome to the Muscle Intelligence Podcast. I'm Ben Pakulski, and today I'm going to interview Dr. Hector Lopez. Who's Dr. Hector Lopez? He's an extremely bright researcher in the area of supplements for performance, in the area of cognitive performance, in the area of CBD. Dr. Lopez and I discuss a lot of new and novel ingredients, what actually works, what has research behind it. Dr. Lopez, as you guys will hear, is incredibly well-versed when it comes to being up to date with the most current research. There's very few people out there on the planet right now who are as fluid with the information that exists in this world on understanding the pathways of function of nootropics, understanding the pathways of function of performance optimization ingredients and supplementation. It's a really interesting conversation. Dr. Lopez, as you guys will hear, is super bright and does it and it teaches us in a very, very simple way that's really easy to understand and gives us a lot of very, very valuable nuggets. So this is a supplement conversation. If you're someone who takes supplements, if you're someone who's interested in performance supplements, particularly around your brain, you guys know I have a fascination with brain optimization and nootropics. Dr. Lopez is a wealth of information. So we get into that as well as some unique and novel ingredients that he has patented that are coming out soon. Some things like a unique type of beta-alanine, a unique type of fish oil, a caffeine analog, something that's parallel to caffeine. And we also get into talking a little bit about CBD and how it works and whether or not you should be taking it. Enjoy the show with Dr. Hector Lopez. I want to give our guests, our listeners, kind of an idea of what you're super excited about right now, because it seems like you've got your hand in a lot of really different cool things. The supplement industry is evolving, seems like it's evolving very quickly. Mm-hmm. And on the other hand, it seems like all the ingredients that are going to be found have been found. I could be completely wrong. It seems like there's a lot of people looking at novel delivery mechanisms, mm-hmm. but you're the guy who's kind of, frontline in the trenches. And I'm curious, what are you excited about? What should we be excited about?
Yeah, so here's the thing, what I like to tell people is, my why, or at least the why from, with the group that I'm working with Dr. Ziegenfuss Timsey, as well as another partner of ours now, Ryan Yates, who's a molecular pharmacologist by training. He's a PharmD PhD. What we're doing is we're using all the learned knowledge that we come across on a day-to-day basis, right, at the CRO, when we're doing clinical research for the industry. And we've actually pivoted and transitioned to using that as an incubator for novel findings, for discovering and bringing to market novel ingredients, like you're probably familiar with, Theacrine. We did work initially with Hydromax, or the glycerol was mm-hmm. born out of the lab. Some of the other things that have come out of the lab is a new ingredient we'll be bringing to market called Carnoprime, which it's kind of like priming beta-alanine. Right. So we're going to be able to get bolus dosing of beta-alanine in a very tolerable fashion, so that we're almost going to be able to treat beta-alanine the way that the old school folks would treat creatine monohydrate, with that loading period, instead of that long, drawn-out 6 to 8 week period where you need to consume a total of about 120 to 150 grams of beta-alanine in order to get the ergogenic benefit. We're going to be able to do it in 7 days. And so we're excited about that, being able to dose beta-alanine at like 20 grams a day. So that's going to be coming to market.
Without the flushing effect, without the GI intolerance kind of stuff.
Exactly. And not using the Carnosine SR currently, which is sort of that slow release. But that's limited to those big, bulky tablets. With our technology, you don't need to dilute the dose of beta-alanine by 50%. You're using a nutraceutical blanket, if you will, to dampen down the itch receptor, which used to be thought that it was an NMDA receptor that would cause the tingling or the paresthesias. And what we found is it's actually an itch receptor. It's another G protein coupled receptor. And so we found a couple of nutraceutical GRAS ingredients. They're generally recognized as safe, DSHEA compliant, and at a certain dose, at 10 to 30% of the dose of beta-alanine, you're able to dial down the paresthetic effect and improve the tolerability, while really taking advantage of the pharmacodynamics of beta-alanine in that it's because of the carnosine synthase enzyme is zero order kinetics. The more you give, the more you make. So it's really just a matter of how soon can you get to delivering that total dose, that 150, 120 to 150 gram dose. So if you can do it in 7 days, with some of these athletes, for example, they don't have the wherewithal or the schedule, the capacity to dose beta alanine 3 or 4 times a day for 6 to 8 weeks on end. If they're like MMA or UFC athletes, for example, they're busy with so much coming at them. It's hard to keep them on point with like a beta alanine supplementation schedule. So here you could get them at the beginning of training camp, hit them with 20 grams a day for a week, and then have them go through training camp. Maybe you can give them another 5 to 10 grams a day the week before their bout, and they can go into their bout with truly elevated levels of intramuscular carnosine. That's just one example of how you could apply that. But the other example is just one of the reasons beta alanine hasn't gotten into the mass, like food drug mass, is because of the paresthesias, even at the lower doses. So now we can deliver lower doses, control the paresthesias. We can almost dial it up and dial it down depending on how much of the carnoprime you use along with the beta alanine. So that's exciting. Omega-3, we have some new omega-3 IP that we're going to bring to market. That's going to be, we feel, is going to be disruptive to the industry, and we're really excited about. So,
tell me about that.
So what we're doing there is, if you really look at, I early on in my career, right, I was working with Nordic Naturals. As you know, you and I have talked a lot about omega-3s, right? That's actually something that always struck me about you is you were really always a cerebral bodybuilder in that, you truly wanted to understand mechanisms. And I really always admired that about you, Ben. So, but
Thank you.
on the Nordic Natural side, that's kind of how I cut my teeth officially in the industry. Yeah. And then I stepped away from the omega-3 world for a little bit, got involved in the endocannabinoid system a lot. So I'm working on connecting the dots, if you will, between the endocannabinoid system, omega-3 mechanisms. And then when you really take a look at all these meta-analyses, I think often what happens is the industry wants to defend itself and poke holes at, well, of course, look at the dose they were using, or they were using secondary prevention, not primary prevention, or vice versa. And so it's easy to poke holes in meta-analyses, and as an advocate of the industry, I was doing that myself whenever a negative study, right, was published on omega-3 or fish oil. But having taken a step back away from the industry, I felt like, and there's more of that data coming out that you even see at doses of, there was a recent study looking at 2.5 grams of EPA and DHA on patients with type 2 diabetes who were obese, who also had fatty liver, who had NASH or fatty liver disease. And the 2.5 gram dose over a 6 to 8 week period, over a 12-week period, did nothing to improve their clinical outcomes, did nothing for their insulin sensitivity, did nothing for their fatty liver, although their omega-3 index went from like 6% to that magical 8 to 9%, which is where we see a lot of the mortality and morbidity benefits. But it did nothing for the primary outcomes, like the reason you're taking the product for. And then when you couple that with all the meta-analyses, we felt like there were some real limitations there. And so what we found is the limitation is it's related to a few things. Number one, it's related to are you familiar with the FADS enzyme, the fatty acid desaturase elongase enzymes, FADS1, FADS2? So that's basically that's the gene that codes for an enzyme called D5D, delta 5 desaturase. This is the enzyme that essentially is responsible for us converting the shorter chain polyunsaturated fatty acids, whether they're omega-3 or omega-6. These are the ones that are responsible for elongating them and turning linoleic acid into arachidonic acid. or turning ALA or alpha-linolenic acid into EPA and then DHA. So part of what happens is that a lot of these studies haven't accounted for the genotype and haven't stratified for individuals' genotype. And it turns out that over half of Caucasians are slow metabolizers. The other half are hypermetabolizers of this, this D5D enzymes, which means that if you give them a lot of precursor omega-3, a lot of like flaxseed oil, for example, they'll go ahead and convert a lot of that because they're hypermetabolizers. They'll go ahead and convert a lot of that to EPA and DHA, which is great for overall PUFA metabolism, right?
Yep.
The problem is that in individuals of Black sub-Saharan African descent, they're 80% of them are tend to be hypermetabolizers. But so you figure that's a good thing if you're in an environment where you have access to a ton of higher omega-3 ALA rich foods. But if you take that individual and you take them out of that, central sub-Saharan African diet or environment, you bring them into the Western world and you feed them a ton of vegetable oil, corn oil, safflower, et cetera, soybean oil, they're going to convert a ton efficiently because they're hypermetabolizers. They'll take a lot of that omega-6, that linoleic acid, and they'll make a ton of arachidonic acid. So hence, you sort of you're set up for a systemic hyperinflammatory state. And, that leads to everything from, more problems with metabolic syndrome, with obesity, with type 2 diabetic complications, and even neuroinflammation as well, which can lead to mood disorder. Now we're finding out, right, that mood disorder is probably just as much a neuroinflammatory disease as it is a quote-unquote neurotransmitter disease or phenomenon.
Do you know what gene that is? So before you
FADS, so it's FAD, FADS. It's FADS1 and 2 genes, and they code for delta 5 desaturase, D5D. That's the main enzyme that's responsible. So if you don't have any ALA in your diet, you're still not right. So you need to still have enough of a pool there, whether that's preformed EPA, DHA, or ALA. But here's the other limitation, is that, and we're seeing a lot of this now with the phospholipid form of DHA, for example, right? That's why people are sort of promoting the use of like salmon roe or krill, the phospholipid versions or forms of DHA. So we found that the limitation is not that you consume it in the phospholipid form, it's that you need to make sure that it's packaged correctly. So if once you have enough of a pool of EPA and DHA and DPA, let's just call them the long chain omega-3s, that's not enough, because it needs to be packaged in a way so that when it's in the membrane, it's localized in an area where all those enzymes are going to cleave it and allow it to participate in all those downstream metabolites that are beneficial, right? All the prostaglandins and resolvins and protectins and mucins. So here's what's interesting. Individuals who have metabolic syndrome or have poor micronutrient status, they tend to package whatever EPA or DHA is in their pool, they package it in the phosphatidylethanolamine form or the PE form, not the phosphatidylcholine form. And it's obligated that your DHA or EPA be in the phosphatidylcholine form in order for you to basically take advantage of metabolizing that EPA or that DHA downstream to get all those benefits, all those physiologic benefits. So RIP basically has found through the use of some screening throughputs and some in vitro, some preclinical models, and now we're moving it into human clinical with our colleague Ryan Yates. We also have access to some supercomputing and artificial intelligence that you put in some inputs and you get some really unique outputs that connect the dots in systems biology. And so we were able to find some phytonutrients that can help to encourage not only improving the D5D issue, but also the packaging, so priming the packaging of your omega-3s. So it's not enough to just throw a bunch. In terms of, there is a genetic component as well. In terms of how you package it, there's a genetic component, but it's not as strong as the elongation desaturation. Environmental enzymes, those enzymes, the FADS1, FADS2, D5D enzymes. So we're excited about that omega-3 IP. We cool. Recently applied for. How
long before that comes out?
That's what you're saying? Yeah, that one, the omega-3, we're probably Q1 of 2019, so pretty soon. We're in the process of deciding who's going to be the, I guess, the licensor, who we're partnering with to bring it to market. I'll leave you with this last kind of IP on the IP side that we're excited about. Is we've semi-serendipitously come across ingredients where when we were looking for nootropic or cognitive, like with dynamine and theacrine, et cetera, we stumbled across an interesting pattern that will impact longevity, wellness, and amplify mitophagy, autophagy, some of these things and even potentially circadian biology as well. So this is the area that's really super exciting. I think there are a lot of individuals, experts in the health and wellness space, probably such as yourself as well, who have recognized the value of circadian rhythm, circadian biology, chrononutrition. How does the circadian rhythm impact when you should be performing some of your activities? Obviously the impact of sleep. And how do we kind of almost hack or amplify those signals so that we can do it easier or we can do it better? And then same thing with autophagy, mitophagy, mitochondrial function, NAD metabolism. So we feel like we found a better way to impact those areas. It's really exciting stuff.
Specifically working on mitochondria, or what's the...
Yeah, so we've got a triad. There's 3 ingredients that we have found that there's synergy for, I guess, maybe 4 main areas of aging and wellness and longevity.
Got it.
One is mitochondrial function and mitophagy. Another one is NLRP3 inflammasome. Another one would be telomerase integrity or telomere integrity. And then finally, the downstream NAD metabolism, so metabolome. So that would be things like sirtuin, global sirtuin function, like SIRT1 through SIRT7, and even some of the other cool things that NAD is a coenzyme for that helps with DNA repair and integrity. So I think we're hitting some of the high leverage systems, if you will, right? That if you're looking for a way to optimize longevity and wellness, these are the pathways that you really want to be. These are the switches that you want to be flipping, whether it's again through your exercise routine, your diet, your lifestyle, what you're doing for mindset, meditation, sleep, and then using these nutraceutical sort of amplifiers, if you will, to amplify some of that signaling. So
you guys have just found a unique synergy between these 3 ingredients.
Yeah, we're excited about that, and so so that's probably going to be coming online here also in Q1 of 2019. And then the third company that helps me stay in touch with what's happening in the industry is the regulatory compliance, Nutravigilance. Where we cover, now we've expanded. Before we were only doing post-market safety surveillance, which basically means, pharmacovigilance in pharma is the study of the safety of products once they're in the marketplace. So any adverse events, any consumer complaints, any serious adverse events that occur with a product, they need to be captured in some way in order for you to know if there a problem with the batch with manufacturing. Is there a problem with an ingredient that we didn't that we may not have known pre-market? Maybe there's an interaction that we didn't understand was there. So that's my third company that really is, I think, gives us. Yeah, I'm really blessed and fortunate to have like this kind of little triad of involvement in the industry, because it kind of gives me a unique perspective from the regulatory safety standpoint. Once products get to market, we've reviewed over 400,000 adverse events and product quality complaints from the industry. We're doing it for a couple of dozen brands right now, from very well-known sports nutrition all the way through the sort of life extension type wellness, health and wellness, healthcare practitioner brands, and everything in between. So that gives us a unique perspective,
So that's just something like a batch test and see what's in there and actually just quantifying the ingredients?
No, so post-market safety surveillance is simply once your product, let's say you had a brand and it goes to market, if you start receiving calls or complaints, which you're going to, right? It's an association, it's not causation. That they took your product and ended up in the ER with palpitations or heart issues or nausea, vomiting, diarrhea, or severe headaches, or allergic responses or reactions. We take all that intake, all that information, we capture it, we put it into their respective buckets. Whether it's an adverse event, a non-serious or serious, or whether it's just a product quality complaint. And then we take those three buckets and we do statistical, like Bayesian analysis, to see if there's a spike in a signal for a particular product that we can then link back to a certain batch or a lot. And then we can interact with, again, like you were saying, what actually went into that lot or that batch? Were there issues with the C of A's? Did they switch out an ingredient? Which, man, it happens more often than not. Sometimes for especially generic ingredients, sometimes excipients. As a contract manufacturer, you're in business, and sometimes if you're trying to improve your margins and you're playing the long game and there's a commodity market out there, you might go long on a particular ingredient or on an excipient, and you kind of switch out what was being used before that might have been a branded ingredient or a branded version. And sometimes when that happens, that can affect once it gets to market, right? You can pick that up post-market. Right. So that's post-market safety surveillance, and then we've expanded that to include pre-market. And the pre-market that's where you're talking about the QA, QC, GMP, to make sure that in fact you're meeting label claim, that you're manufacturing, that you're following MMRs, master manufacturing records, et cetera. Yeah. So that's the complete, like, pre to post-market regulatory compliance that most brands should be. They should be doing, or they should be following. Not all of them do, because sometimes entrepreneurs want to bootstrap a new brand and just come to market, and there's a low barrier to entry sometimes, right? So yeah. So between those three areas, that's kind of what I'm doing.
I know you can't talk about specific brands, but are there specific ingredients that maybe are commonplace that are coming back again and again as having become issues, or is there things that we thought in the past would be efficacious and useful that we perhaps know now as being perhaps less than ideal?
I can say the one that I don't think is, it's not necessarily going to put me into a scenario where, because as you can imagine, I'm sort of sort of like a priest, who's hearing confessions sometimes, and hearing everyone's darkest, deepest secrets. But I will tell you this, something that surprised me actually, and is that oftentimes the combination of a probiotic from various strains, not just the lactobacilli or not just the bacillus coagulans or something, combining probiotics with a protein in one product, that oftentimes ends up, we end up seeing a spike if a brand didn't do that before, or didn't have a probiotic in their protein, and they implement a prebiotic or probiotic to modulate the microbiome. You end up getting a spike in complaints, usually GI complaints. And so part of what's happening there is that Some of these organisms are spore-forming organisms, and so when you have them in a scenario where there's nutrition for them to actually break out of their spore and start germinating, they can sort of increase your microbial counts a little bit. That's one scenario. Water activity within the product. So from a microbiome modulation standpoint, it's a little tricky, because if you're going from a scenario where you've sort of been steady in your diet and your microbiome, and now you alter it, that transition can end up causing GI complaints, right?
Sure.
And so some consumers aren't aware of that. And so that may end up causing a big spike in consumer complaints. And it just takes, so part of what our team does is we're all healthcare practitioners with a background in supplements and understanding GMPs and the manufacturing process, and understanding ingredients and their mechanisms and how they work. And so part of this ends up having us needing to reassure the consumer about what they might be experiencing and why. But sometimes it's a real issue, like the former that I mentioned before. So
you mentioned 3 areas there that are kind of hot buttons for myself and my demographic, or at least earlier you did. So nootropics is a big one for us. Obviously, mitochondria is a massive one, as you know, and CBD is another one. That's cannabinoids is a very, very interesting topic right now. I'd love for it to just like kind of walk through each of those, starting with nootropics and saying, maybe a few things you can about, what ingredients are exciting. Obviously, we know theacrine is an exciting ingredient. Dopamine is an exciting ingredient. Our listeners are, obviously our BS radar goes off a lot because there's so much out there. And it'd be cool to hear from yourself what is actually maybe the most validated from a scientific perspective as far as having clinical benefit.
So as far as nootropics, I mean, I like to break them up into acute, like neurocognitive acute sort of ingredients, or ingredients that are going to have a more impact acutely after consuming the product, versus a more of a sustained chronic, neuro restoration, neuro repletion, and even neuro resilience supplement protocol. So I think when you look at it acute, if you want to impact somebody's neurocognitive performance acutely, you need to do a few things. I think you need to start with attention, arousal, and focus, right? And so then you look at ingredients that have been shown to impact attention, arousal, and focus. And I think those are ingredients that typically operate along the adenosinergic pathway, along the cholinergic pathway, and also even dopaminergic to some extent. Dopaminergic can be a little more mood motivation based, typically. So if you can alter someone's dopaminergic signaling across various areas of the brain, with the basal ganglia talking to other areas in the cortex and vice versa, you can impact motivation and mood. But choline is a cholinergic. Acetylcholine is obviously the main one to affect for attentional focus and working memory. So some of the ones I like there are, I think, your common ones, your common players, which would be things like alpha GPC or CDP choline or CD-choline. And then you can also indirectly impact cholinergic signaling by using things like huperzine A, which actually impact the enzyme, right? Acetylcholinesterase, the enzyme that breaks down acetylcholine. So I think those are your main players in terms of cholinergic responses. I would say are alpha GPC, CDP choline, huperzine A, again through a different pathway, indirect. Another indirect pathway, probably things like Bacopa Manieri and the Bacopa sides, as long as it's standardized for Bacopa sides. That's
influencing choline?
Yes, yeah. Also acetylcholinesterase inhibition, yeah.
Similar mechanism to huperzine. So I've seen some data around huperzine that suggests having a pretty poor long-term effect, like as far as actually shutting down the enzyme, which could long-term affect acetylcholine levels. But I haven't seen the same data on Bacopa, but they are working very similarly.
They are working very similarly. You know, often what happens here, Ben, is it's actually something we found, for example, with the methyl urate compounds like the theacrine and methylliberine that we're working with, is even though they also hit like the adenosine pathways, like caffeine, like methylxanthines do, they do it differently because how they interact with their target, like the whole, ligand receptor or ligand enzyme interaction, the structure activity relationships, they can work on the same pathway or on the same overall mechanism, but how they interact can affect if you're going to get downregulation of the enzyme or the receptor over time. So I've also seen and actually anecdotally observed similar things as what you mentioned with huperzine A. So I tend to be less of a fan, honestly, of huperzine A for that same reason. I think you're better off kind of providing more substrate for the cholinergic pathway. So the precursors, things like alpha GPC or CDP choline. If I'm going to tickle the cholinergic pathway, that would be my preference as well. I think what's happening with Bacopa probably is I'd need to look at a little more of the potentially the molecular pharmacology or structural biology aspects of it in terms of how it's interacting. It might be like an allosteric modulator of the enzyme, so it might not be as strongly competitively inhibiting the enzyme. It might be a non-competitive inhibition or some other more subtle mechanism, which is what we're seeing is happening with theacrine, and we're actually doing some of these molecular mechanistic studies right now, actually, and we're seeing some really cool things about how theacrine and methylliberine interact with the adenosine 2 receptor, A2A receptor, and even the dopamine receptor differently than caffeine, and why it's possibly responsible for why you don't get a lot of the same sort of physiologic responses, right? You don't get the habituation, you don't get the withdrawal or discontinuation syndrome the way you do with caffeine. So the same thing might be happening with Bacopa versus huperzine A there, cholinergically. And then in terms of affecting arousal, the obviously the one that people go to globally is caffeine, clearly. Because adenosine is an interesting neurotransmitter system. You need adenosine because adenosine is actually part of what contributes to like mounting sleep pressure during the day and fatigue.
Yep.
So you do need adenosine, and adenosine has its own other functions that are important, both in the brain and even peripherally. So you don't want to continuously block it per se, the way that you tend to do with caffeine. Caffeine's a very strong antagonist of the adenosine A1 and A2 receptors, A2A receptors. So, but it's an effective way to ramp up the arousal sleep-wake centers, in the arousal system. There's a part in the CNS called the reticular activating formation and system, the RAF, and that's an important system to improve arousal, especially in individuals who have been sleep deprived or might be sort of experiencing neurofatigue. And then in terms of some of the more chronic ingredients that I like for nootropics, is actually, okay, so what are the other areas that are important? Well, you want to make sure that membrane is healthy. So things like phosphatidylserine, things like EPA, DHA, omega-3 status. And then you also have some repletion strategies like L-tyrosine to help replete some of these other important neurotransmitters like norepinephrine and like dopamine as well. And then there's a couple of other pathways that I think are underutilized in nootropics currently because they're seen as more mood based, but there's a lot of crosstalk there, right? There's a lot of interplay between the mechanisms that can alter or affect mood and the mechanisms that can alter and affect cognitive function, working memory, executive function, et cetera, thought processing. And that would be those kind of mood modulators would be things like 5-HTP, obviously, and serotonergic pathways. But even other aspects of mood modulation could include things like, have you heard of the mesembrine alkaloids? There's an ingredient called zembrin, for example.
I think I actually just came across that last week. I'm not very familiar with it, though.
Yeah, so zembrin is an ingredient from Scaledium tortuosum is the botanical extract, and it's rich in these mesembrine alkaloids. And what they do is they tend to affect the phosphodiesterase enzymes. And so the phosphodiesterase enzyme, if you inhibit phosphodiesterase, then it means you basically amplify cyclic AMP and cyclic GMP signaling.
With what result?
Well, so cyclic AMP and cyclic GMP, depending on which phosphodiesterase subtype or enzyme that you inhibit, can actually amplify. It's kind of downstream of, for example, once serotonin interacts with this 5-HT1A or 2 or 3 receptor. When serotonin binds to the serotonin receptor, downstream of that, you're going to have, it's a G protein coupled response, so you're going to have an increase or a decrease in cyclic AMP and cyclic GMP. And so these mesembrine alkaloids, by affecting those downstream compounds, those biochemical compounds, then you're also going to affect that signaling cascade, that signal transduction. So you can amplify serotonin neurotransmission, right? With things like Scaledium extract. I think zembrin is the one of the branded ingredients that has been studied clinically.
Yeah, I was talking to someone about that last week, and they were suggesting it for sleep. That's why I was curious if it was just basically a mood and a calming type thing.
So it can be, right? Because sleep is that's a whole other, that's a pretty sure, complex, yeah. Right? Yeah, topic. Yeah. But sleep requires this almost, I would call it like a symphony or an orchestra, right, of different neurotransmitters that are being regulated, that are modulated, almost like a graphic equalizer, right?
At different times,
right?
Yeah, yeah.
Right. So I think one of the interesting things are ingredients that you would normally think could be activating or stimulating, like even cholinergics, for example. They've been associated with increases in lucid dreaming, and probably increasing REM states. Now, what does that do to non-REM states, right? Who knows?
Sure.
Right, but,
I've actually tested it. So our mutual friend, Scott Hagerman, suggested taking alpha GPC before bed. And I was like, okay, let's test it out. I actually did notice more restful sleep. He suggested there may be some type of growth hormone increase. I don't know that I saw any of that, but I definitely did notice potentially, again, subjectively increased
like quality,
sleep.
Like restful, like sleep quality.
And I was quantifying it with my Oura ring and trying to see if there was any significant statistical difference. And I don't know that I saw anything significant, but as far as perceived difference, I was taking a lot though. I was taking about 1 gram before bed, which is a very high dose for most people.
Yeah.
But yes, I took 1 gram in the morning, 1 gram before bed, and did that for about 4 weeks, and there was a difference, absolutely. So, but it wasn't affecting. I assumed it was going to negatively impact my sleep and keep me awake.
Yeah, no, that's interesting. We came across a similar scenario actually with Theacrine. Is that it can actually increase sleep quality, but when you measure it using something called the Pittsburgh Sleep Index, Pittsburgh Sleep Index Quality Scale, or Pittsburgh Sleep Quality Index. I'm sorry, PSQI. It's a very well validated instrument, right? Measure of sleep quality and quantity, not just one versus the other. And so we saw that with Theacrine, that it was it was antithetical to it being a quote unquote stimulant. So it's not a classical stimulant because it could actually improve sleep quality index scores as long as you take it far enough away from caffeine. Because if you take it with caffeine, then it can actually increase the half-life of both caffeine and theacrine. So now you'll have both of them for a longer period of time, and obviously caffeine could definitely disrupt in some individuals.
So if I was to take theacrine on its own before bed, I would actually improve my sleep?
That's what some of our data has suggested. Yep. And actually there's one animal study that we didn't do. We didn't sponsor this animal study, but it actually looked at the sedative effects of theacrine when it was combined with phenobarbital. Now, phenobarbital is a very potent sedative, right? As you can imagine. But what it showed was, compared to placebo or vehicle, when you added theacrine to phenobarbital, it decreased sleep latency and it increased sleep duration. So, whereas caffeine actually did the opposite.
Can we walk through the mechanism of theacrine so the audience knows? Because I mean, I've been using it for a long time, thanks to you.
Oh, cool.
And I absolutely love it, man. You know, I'm a huge fan. Absolutely, still use it whenever I can get my hands on it. Yeah, I mean, great product. So what I find though is there's a lot of products out there where it's, you know, mixed in with other stuff, and myself being the mad scientist, I'm not often taking other multi-ingredient combinations, right? I'm usually kind of mixing up my own brew and you know, doing what I need based on the scenario, right? I want a different concoction for working out compared to studying, compared to, you know, writing a novel or something, right? So, so I'm trying to find isolated ingredients, but I'd love to hear the pharmacology and pharmacokinetics of how that works.
Yeah, so theacrine, we like to call it a neurobioactive compound. It's in the family of purine alkaloids. So if you look at like the chemistry of it, it looks very much like other purine alkaloids. So what are examples of other purine alkaloids? That would be things like theobromine, like caffeine, right? Like hypoxanthine.
It's sourced from chocolate, is it not?
Yeah, you find it. You can find it.
Yep.
Yeah, we're actually doing organic synthesis. Yeah, so we're synthesizing it. Only because it's more cost effective that way, and also it gives us more control. It's like an active ingredient that we know is nature identical, but we can control the synthesis, so we know the inputs, we know the outputs, as opposed to having the potential, you know, changes with harvesting and extracting from naturally occurring sources, and you've got a slew of other compounds in there that
solvents,
right. So, and we have done that as well, and we have that available. It's just it's 3 times as expensive and more variable in its effects, right, from season to season in terms of harvesting, etc. But yeah, it's naturally occurring. It's naturally occurring in there's a fruit called cupuaçu, which is Theobroma grandiflorum. And so Theobroma is the same genus. They look like cocoa pods, so it looks like chocolate pods, right? And so when you crack these open, they've got this white sort of fleshy substance inside these cocoa pods, and there's about 4 to 6% theacrine found there. Then there's another source called Camellia assamica kucha. It's a kucha tea that grows. It's a type of tea that grows in a certain region, certain elevation. It's the Hunan region in China is known for using this kucha tea, and they've used it everywhere from for things like chronic fatigue to, you know, some traditional sort of health ailments, right? The flu, influenza. Some of the local area high school students and collegiate students use it for studying, etc. So they use the tea. Right. That also contains about the kucha tea. When you steep the tea, you could probably get anywhere between 60 to 65 to 70 milligrams of theacrine in a cup of kucha tea. So it's found in that tea leaf. Now, what's interesting is it's found along the same synthetic pathway within the plants as you need in order to make caffeine, or in order to make theobromine, which is also found in coffee and some chocolate, obviously cocoa species. So it's in the same general family. But what people don't realize is, to the untrained eye, if you look at the two molecules, like if you look at caffeine and you look at theacrine, they look very, very similar. But one is trimethylxanthine. It has 3 methyl groups, and it's a xanthine. The other one is tetramethyl uric acid, which means there's a 4th methyl group, and it's a uric acid, which basically means the difference between uric acid and a xanthine is that the uric acid part of the molecule has a ketone group, a carbonyl and oxygen group off the molecule. So you have one extra methyl group and an extra oxygen ketone group, which again, to the untrained eye, otherwise structurally it looks almost like the same compound. But those two differences can have an enormous impact on the pharmacodynamics of how the molecule works when you ingest it in the body, right? So, we've seen that. We've seen that preclinically in animal studies. We've seen it in vitro, and then we also have seen it in all the human studies that have been published on theacrine, as well as combinations of theacrine with caffeine. So one of the differences between theacrine and caffeine is, while caffeine is a strong inhibitor of the adenosine A1 and A2A receptors, theacrine, what we have found is likely not as a strong antagonist to those receptors. What it's likely doing is, we feel like the interaction with the receptor is different because of those slight changes in the molecule. It changes the way that it interacts with the receptor, and what it's likely doing is modulating it slightly. So it might be changing the conformation of the receptor, but not completely knocking it out. And when you don't completely knock out a receptor, you still allow some of that signaling to take place. And that's why we feel like one of the reasons why you don't get the palpitations, blood pressure, hemodynamic responses, right? The cardiovascular responses that you get with caffeine. But one of the other things that change in the molecule does is it allows it to act directly with the dopamine receptors, D1 and D2. Whereas caffeine has an indirect effect on the dopamine receptor. So with theacrine, you've got more dopaminergic signaling, to make it real simple, more dopaminergic and less of an inhibition of the adenosine receptors. So that's where the difference lies between caffeine and theacrine. That's just one of the differences, but yeah.
To break it down for the listener, it's just going to make you feel a little bit better than caffeine.
Yeah,
Caffeine
a
will
little
lift
more
you
mood.
up more.
Right. Yeah, so a little more energy. So caffeine, more energetic, more activating, if you will. And also the kinetics are different, meaning it's going to be in and out within 1 to 2 hours. Sometimes 3 hours, depending on your genetics, right? The enzyme that actually breaks down caffeine, the cytochrome P450 genetics. But for theacrine, it's much smoother, slower tail. So it's going to take about 2 hours to even start reaching peak levels. It stays at a peak for about 4 to 5 hours, and then a slow tail. So you can get up to 6 to 9 hours of theacrine-based activity, and that's why initially some of the subjects would, when we were doing some of the initial beta testing, they'd feel very subtle, like, wow, I took the theacrine this morning, and 2 hours into their day or into their drive, it's like, I'm really productive, I've got a good mood, I feel good, I've got I'm kind of on, people would say, like, I feel like I'm at my best. If they're doing work with spreadsheets, or they're writing, or manuscript writing, or something like that. So and that's one of the reasons why it's the difference in the kinetics. It's also the difference in the mechanisms. It also affects other neurotransmitters by itself. Also, we normally don't talk about this because it gets really technical, but it also does a little bit of that phosphodiesterase inhibition. It also inhibits another enzyme called xanthine oxidase. So, because ironically enough, the xanthine oxidase is the enzyme that makes uric acid. So people who have gout tend to either be overproducers of uric acid, or they're not excreting enough of their uric acid, right? Which comes from sources that are high in purine. If you've got a lot of tissue turnover, you're excreting a lot of uric acid. If you're consuming a diet that's rich in purines, usually animal meats, organ meats, are usually high in purine. So people with with issues with uric acid metabolism tend to get gouty attacks. So theacrine actually is a mild sort of anti-uric acid compound, because it actually helps to slow down the enzyme that makes uric acid. One of the interesting things about that enzyme is that it's what's called it has a high oxidative burst, and it's almost like a pro-inflammatory enzyme. So the more uric acid you're making, the process of making uric acid, it's highly oxidative, even though uric acid itself is sort of a naturally occurring antioxidant. So it's interesting how that works. So it has anti-inflammatory activity, theacrine does, much more than caffeine does. And it's doing some other cool things. So there's
cool.
actually an animal model showing have you seen that study where it actually shows neuroprotective benefit, theacrine does?
No, I didn't see that.
Yeah, so I should send you that study. It's actually really cool in an animal model. Yeah, it's
very cool. Love to see it.
Yeah, so there's other things. There are other things going on with theacrine beyond caffeine. Yeah.
Very cool, man. Definitely an exciting compound. Now, I want to jump into a little bit of the cannabinoid system, talking about that, because it's obviously the hot topic of discussion these days. And I mean, everybody's jumping on the bandwagon, and I'm doing my research. I'm doing my due diligence, and to be honest, I know absolutely nothing about it. But I'm relative to most people, kind of diving into that world, so I can have a bit of a grasp as to what's going on. I'd love to kind of have you enlighten us on where your involvement is in that space now, and if you've seen any novel ingredients that combine well with, CBD or influencing the endocannabinoid system.
Yeah, it's actually a fascinating system. So I got involved with the endocannabinoid. The first time I actually came across the endocannabinoid system was not in my nutritional biochemistry training. It wasn't necessarily in my medical training.
It was in college in the bar.
Yeah, that's right. That was my first experience with the endocannabinoid system directly. But even just academically, like, it's not something we covered, right? Like 15, 20, 30 years ago, it's not something we covered. So, but I actually came across it while I was working a lot in the omega-3 space. And the reason for it is because there's crosstalk between your omega-3 status, omega-6 to omega-3 status, and your endocannabinoid tone. The reason being is that the very backbone of your endogenous cannabinoids are omega-6 fatty acids. There are also omega-3 based endocannabinoids too that we're discovering now as well. So really, the endocannabinoid system, just to back up very briefly, it's the culmination of you have a signal, the endocannabinoids themselves, you have receptors, the cannabinoid receptors, and then the other part of the system are the enzymes responsible for either synthesizing the cannabinoids or breaking them down. Now, you have CB1 and CB2 are the main receptors. THC, or tetrahydrocannabinol, obviously is very strong agonist to the CB1 receptor, and that's what gives people the altered sensorium, the high, essentially. And the CB2 receptor is found, and the CB1 is very dense within the brain, within most of the regions of the brain, except for the brainstem, which is why you really don't hear about fatal overdoses with cannabis, is because it doesn't impact the cardiorespiratory centers in the brainstem, in the medulla. There are no CB1 receptors typically there. CB2 receptors are mostly found in the immune system, and that's found throughout the entire body, including the microglia of the brain, which you can think of that as the immune system of the brain, right? Effectively. Whenever there's brain injury, the microglia gets activated, et cetera, et cetera. So now I came across hemp-derived phytocannabinoids, probably, I guess, going on 5 years ago now. One of my very good friends from Nordic Naturals, Stu Tomp, took a position as a VP of Human Nutrition at a company called CV Sciences, or CVSI. So CV Sciences is the company that launched a brand called Plus CBD oil. I think them and Charlotte's Web or CW Hemp are probably the two largest retailers in the US of phytocannabinoid-rich hemp-derived products, things like CBD, but there's so many other compounds in what are known as full spectrum hemp extracts versus isolates. And I think there's a lot of confusion out there, Ben. There's so many products right now on the market. It's hard to know who to trust, what the source is.
Absolutely.
So I would highly encourage consumers that want to experiment in this space to contact their brands and actually find out if their brand is, have they done any toxicology studies on their actual ingredient, on their article of commerce? Are they sponsoring any human clinical trials? We're currently doing a couple right now at our CRO. We're fortunate enough to be able to do that. We've done some preliminary pilot work already before that. And so, yeah, I think it's important to understand, source, potency, extraction method, and then there's different products for different purposes for different people. So there's CBD isolate, which is actually like the 99% plus isolated cannabidiol. Usually it's a crystalline form in order to get it that isolated. Yep. CBD isolate is a very different product, completely different product than a full spectrum hemp extract that might only have 10 to 25%, for example, CBD by weight. And I think that's one of the biggest confusions that you see in the marketplace is people just, they want to call everything that's a hemp-derived product or that has CBD on the label. Well, CBD is CBD no matter where it comes from. Yes and no. Cannabidiol is sure, it is a unique, it has a unique, chemical formula and molecular structure, et cetera. But even CBD, people don't realize CBD has 2 chiral carbons, 2 chiral centers, which means you can have up to 4 stereoisomers of CBD itself. And what's interesting is if you have a CBD isolate that's a synthetic, like it's synthesized in a lab from petroleum sources versus an isolate that is extracted from a plant source, you end up having a different stereoisomer ratio or mix of the CBD.
I didn't even know that was a thing. I didn't even know you could extract that from petroleum. That's interesting to know, and hopefully not too many companies are actually actively doing that.
Yeah, well, the reason it's petroleum, honestly, Ben, is because the carbon source, like your starting material to basically make the ingredient is a synthetic, right? So it's it's petroleum-based carbon versus... And you could actually, there's a way to analyze it using like carbon-14, like ratio, like isotope ratio testing to see it. Is this actually, is your 100% CBD product, is it from a natural botanical source or is it from a synthetic? And look, there's a role for the synthetic as well in pharma potentially and for other purposes. But one of the interesting things about it is that the synthetic cannabidiol has a certain stereoisomer. It's a negative, it's a minus CBD. It actually is an activator of the CB1 receptor. It has more binding affinity to CB1, which is exactly the reason people usually take CBD is to try to not have the CB1 activation, right? And again, most consumers have no idea about that. Some brands, honestly, that are just getting into this space don't even understand. There's a lot of nuance. Totally. There's a lot of nuance there.
I mean, Doc, so much incredible info, man. I got to come spend some weeks or months at your lab and just dive into your brain there a little bit, man. Thank you so much. I've got to wrap that. Love to know where we can learn more from you. And I want to promise that you're coming back really soon or that I can come down and shadow you in the lab.
Yeah, no, I mean, we've got a lot to catch up on. It's been a while since we touched base, so I'm glad we were able to do it here. And hey, man, I apologize that I didn't realize that we were already on the first half of that. I thought we were just kind of catching up, but as a stream of consciousness, I guess.
No, man, you did. That was incredible. So much information and all valuable, applicable info for our listeners, man. So again, very, very grateful for your time.
Yeah, so I'm basically, I don't do much social media. I'm on Twitter occasionally, and then through my companies, through Supplement Safety Solutions, there's a website, and then the Center for Applied Health Sciences, there's a website, and then there's some other stuff coming with the new IP company that we have, where we're bringing all these new ingredients to market and leveraging artificial intelligence along with preclinical all the way through full stage clinical testing, so that when we bring an ingredient to market, we know that it's fully vetted. So,
Man, thank you so much.
Cool. Thanks a lot, Ben.
Thank you so much for tuning in to Muscle Intelligence. If you enjoyed today's episode, please be sure to share it with at least one person you know, and make sure you're subscribed so you never miss an episode.